Today is Sunday, February 23rd, 2020. This is an interview with Dr. Peter Liaw, who is a professor and Ivan Richard Chair of Excellency at the University of Tennessee, Knoxville. The interviewer is Michael Gale. This interview is being conducted as a part of the American Institute for Mining, Metallurgical, and Petroleum Engineers Oral History Project. We are sitting in the Marriott Marquis in San Diego during TM's annual conferences and are going to discuss his experiences in material science and his contribution to the field. So now let's get started with the questions about childhood, schooling, and interest of engineering. Could you please tell me about where you grew up and your family?
Thank you, Dr. Gao. It's a pleasure to be here. I was born in Jiayi, Taiwan. That's in the southern part of Taiwan. And I went to Jiayi, middle and high school. And after that, I went to National Tsinghua University in Taiwan. I studied physics. Then after that, I went to military service for 2 years. I was a second lieutenant in charge of 5 tanks. So I was getting trained in there. Of course, it's tough, but we went through it. And after that, I went to Northwestern University, Material Science and Engineering, to study certainly material-related topic. My advisor is Professor Morris E. Fine. I work on my PhD related to fatigue performance of aluminum alloys and steels. I stayed there for about 5 years. And I work at Westinghouse Research and Development Center for 13 years, from 1980 to 1993. Then after that, I joined the University of Tennessee as a faculty member there. Of course, I get quite a lot of help from my colleague of Oak Ridge National Laboratory, and certainly including Dr. Gao, who helped us on many calculations, co-advise quite a few PhD students. And at Oak Ridge, I met many colleagues, in particular Professor C.T. Liu really helped me quite a lot. Since I joined the department at Tennessee, Dr. Liu gave me a contract until he retired, working on intermetallics. Of course, he quite famous in that area, and we co-advise many PhD students and write many joint papers.
Okay, good. Next question is, who or what influenced you to become a professor?
That's a very good question. Yeah, actually, my grandfather wanted me to get into medical school, but I was too much interested in physics. That's why I studied physics. Now, when I graduated from Tsinghua University, I thought if I continue my physics education, perhaps it could be somewhat difficult to find a job at that time. This is why I decided to study material science engineering, and I happened to have a scholarship from Northwestern, so I went to Northwestern. Although I'm grateful to the support from University of Pennsylvania, they gave me scholarship in physics, and also University of Washington Physics Department. Sometimes I'm wondering if I study physics, what's going to happen to me. But when I was at Northwestern, certainly, my professor, Morris E. Fine, is a wonderful person. He is a scholar and a gentleman. And I look at his career, and he was a Bell Lab for, I believe, 9 years before he joined the faculty at Northwestern. So I said, well, maybe I should do the same thing. And so this is why I went to Westinghouse. Now, after that, I joined the University of Tennessee. But teaching is always interest, because I like to interact with young students and help them as much as I can. Also, I have more freedom to what we like to do, provided somehow if we can be successful getting money. As you know, it's so competitive, and we are always writing proposals all the time. But being a professor is always on my mind, especially I saw what my professor, has done in his career.
Okay, thank you. Did any of your professors mentor you in any particular way?
Yeah, certainly. As I mentioned, Professor Morris E. Fine, he influenced me quite a lot. And also there are wonderful faculty members at Northwestern University, Professor Julia Wortman, Professor Hans Wortman, Professor J.B. Cohen, Professor Mesh, Professor Hidia, and Professor Schwartz. They are all very wonderful people, and they will set up excellent example for all of us. And of course, they enjoy teaching, they enjoy interacting with many students, and that's set up a stage for me to become a professor, even though I was working in industry at Westinghouse. And certainly when I was at Tsinghua University back in Taiwan, many of my colleagues, they are top talents at that time in the country, because they all are interested in studying physics, and many of them, probably 35 of them, came to US to get their PhDs. And we all talk, and certainly we all enjoy research, and if we could, we certainly like to become a professor, besides the possibility maybe working in industry.
Thank you. Did you have any classmates that influenced your studies?
Oh yes, especially at Tsinghua University, we all work together as a team, and we all talk. And many of my classmates really help us, and we discuss. To this day, we still communicate with my classmates back in Tsinghua University. As a matter of one of them, Su Qing, he would come to the dinner Tuesday. And also at Northwestern University, many are friends there. And some of them went to industry, some of them went to the academics. So we all interact, and they influence me quite a lot.
Okay, good. And did you have any influences such as religion or mentors?
Oh, I always since I was in high school, I went to meet American Missionary, Miss Johnson, and it's in my hometown, for the purpose at that time to study English, but I also studied the Bibles, and she also helped me quite a lot. I wonder what happened to her now, but I always remember she told me that the reason she came to Taiwan because she was sitting at the last pew in a big church, and her preacher said, "Is there anyone want to go to Taiwan?" And somehow he stood up, walked from the last pew to the front desk, and then she sold all her properties, put into bank. So every month the bank pay her some money, and just away she stayed in Taiwan for many years, helping many Taiwanese or Chinese there, and that I come to know Christianity. Yeah. And then along, there are many teachers helped me at Tsinghua University, and certainly at Northwestern University. I still met my physics teacher, Dr. Ke Lin. He taught me maybe modern physics back in Taiwan, and I still see him. I saw him actually last year when I went back to Taiwan. He just retired, and it's funny that I tried to be a matchmaker for his daughter.
Professor Liaw, so could you tell us a bit more about the early childhood of your family? Your family in Taiwan.
Thank you. I was born in Jiayi, Taiwan, the southern part of Taiwan, and certainly my father and my mother, and they are always very loving, and also my grandfather, especially my grandfather, he's highly educated, and he always wanted me to become a medical doctor, but I was too much interested in physics, so I studied physics. But they always encourage us to get the highest education, as much as you can. So I got their encouragement and continue to study, especially to this day, even though my parents, my grandfather, of course, they passed away. But my mother always told me that as long as you study very hard, you will have a chance to travel all over the places. And she is absolutely correct. So we are all encouraged to study very, very hard and make the best out of what we have. And education is always the most important thing in our family. They will sacrifice everything for the families, educations. Yeah.
Are you the only child in your family?
Well, good question. I have one brother and one sister. My brother is in Taiwan. My sister is in California. Actually, she's coming in tomorrow, for the dinner. Yeah, so.
Okay.
And they are all very loving and very nice. Yeah.
Okay, good. Thank you for sharing that with us. Would you mind telling us more about your family in America?
Oh, I have my wife. She's upstairs. And she came with me to TMS meeting. And I have one son. He studied medicine. Now he practiced medicine. We are grateful that he's working in Knoxville, so staying with us. And my son, he got married, Katie, and they have a son, so I have a grandson, who is about 7 months old. And my daughter also studied medicine, and she is at University of California, Davis, because her husband finishing up his medical school there, and they have a daughter and she is about 1.5 years young, and they are all lovely, wonderful kids. Yeah. And being a grandfather is the best. You just play around with the kids, and you don't need to take care of them.
Okay, it's good. Thank you for sharing your family information with us.
Thank you.
So now we're looking into entry into profession. So some questions going to follow up. What are some of the biggest technical challenges that you experienced in your career?
Of course, try to finish up your PhD is always a big step, and but my professor Maurice Ifan always help us along the way, and I did fatigue work on fatigue, crack propagation of aluminum alloys and steels, and if I have difficulties, he always try to help out. And because of his help, so I know many people because he's a very famous person. And he also encouraged me to come to this AIME type meetings, and I have many friends. So if I have a difficulty, I can talk to my professor, my friends, and they are also nice helping out. So this is for my PhD study. And then at Westinghouse, of course, when you just go to work for companies, it's different. And fortunately, I have very good colleague there. It was one of the best fraction mechanics group in the world at that time, because Westinghouse is building nuclear reactors, turbines. They need lots of fraction mechanics background, so they have one of the best in the world. And my colleague, Professor John Landers, Professor Norman Dowling, later on they all become professors. And Dr. Steve Hudak, Professor Ashok Saxena, W.G. Clark, Bill Clark, he was my boss. At Wesel, he was my boss. At Wesel and W.G. Clark, they helped me. And I always remember when I went to Westinghouse, I tried to write papers. And W.G. Clark always said, Peter, let me share with you how to write papers. So he took me aside and showed me you should lay out your paper outlines and clearly, and maybe some figures, and start to write down what you are supposed to say. And he always says something to this day. I always share that with my group member, that writing is learning. You have to write to know something well. And that's I really learned from him. So I'm grateful for my experience at Westinghouse. Of course, they helped me quite a lot, give me lots of opportunity there, and so I can do work on fracture mechanics, fatigue and fracture mechanisms, publish a few papers. This is why I can go back to academia to teach. And then when I went to university, certainly it's totally different. You're from industry, going to academia is a big change too. Even though I was writing quite a lot of proposals at Westinghouse, but at university it's somewhat different. Also, people seem to say that if you can survive at Westinghouse, we have a 12-time layoff at that time at the Westinghouse Research and Development Center. So someone always say that, well, if you can survive at Westinghouse, you can survive at any places. And that could be true, because it's very tough. At Westinghouse, every week you have to fill out just 40 hours that workload sheet. And if you don't have money, and on your program, you charge the overhead. If you continue for 1 or 2 months, you probably will be gone. So we are encouraged, to write many proposals, and we got to know how to deal with customers, so they're happy with you. They can continue to give you money from our division or from outside Westinghouse in the Air Force or EPRI, Electric Power Research Institute. So it gives us lots of experience in terms of how to get money to research or how to sustain our programs. So I'm in debt to Westinghouse for giving me this opportunity. And as I mentioned, when I went to University of Tennessee, it's certainly totally different environment. But I also have very good people helping me. As I mentioned, that Professor C.T. Liu always helped me. When I arrived at the university, contact him, he gave me a contract already until he retired, just after about 15 or 16 years, and always give me a contract. And also, I remember Professor Carl McCarr. He was a director of our Center for Material Research. And when I arrived at UT, I have nothing. So he said, Peter, I have a program for you. This is on silicon carbide reinforced ceramic matrix composites. At the time, it's a very hot topic. And here is a student, Narim Minyala. You just take care of him, write papers, and all the money belongs to US. Okay, so people really try to help me so much. And my colleague, Professor Ben Oliver, he was an NSF director And of course, I started to write my first NSF proposal, and I always remember he gave me his proposal. Peter, why don't you take a look at this? Is the proposal I have, and then I learned from it. And so there's so many people helped along in my career. So I appreciate that opportunities at universities. Of course, we are always writing many proposals. Dr. Gao knows we fail many times. But the lesson I learned is that you should never give up, to keep on writing. In many cases, we write, it took us 3 or 4 times to get money from NSF, National Science Foundation. My colleague, Professor Yang Gao, we actually tried 7 times before we get a program. So it's tough. But I think if you stick to it, continue, you will be successful. Maybe the program manager says, well, I see this proposal too many times. Perhaps I should give him or her some money to play around with, otherwise they'll come back again.
Professor Liaw, could you please share some of your technical contributions to the industry?
Thank you for the question. I don't know what kind of contribution I have in industry. However, I appreciate the opportunity that I work with my colleague, Professor Ashok Saxena, who is a top-notch high-temperature fracture mechanics engineer. And later on, he became a professor at Georgia Tech as a professor and then department head. Then he went on to University of Arkansas, become a provost there. So we worked together at Westinghouse. I learned quite a lot from him, and we work together. We have contract from utility companies and from EPRI, Electric Power Research Institute, and we focus on life prediction of high temperature component. Just to give you one example, if the utility is operating steam pipes, and if there's a rupture, for example, steam pipe going through the restaurant, and when it ruptures, the steam coming out is a high temperature, high pressure, so it's just like a Japanese saw. It cuts through the people. It's a dangerous adventure. If this happens, especially when someone gets hurt, and it actually happens, then utility will say that, well, the piping company is not doing a good job because we got defected pipe, and that's all your faults. The piping company will say that this is utility's fault. You didn't follow the standard procedure to operate your piping system. So then they get into lawsuit, a big lawsuit. We're talking millions of money. And if you shut off those piping systems, maybe one day could cost 1 million. Depends on what kind of system you have, especially for nuclear reactors. So it's important to predict the life of an elevated temperature structure component. You have to inspect it, or if you see a crack, then you have to estimate how much longer before the rupture occurs so we can avoid all those kind of accidents. And so this is why the fracture mechanics or high temperature life prediction is very important. And Professor Saxena and I will work on this topic, and we wrote several papers in this area. And some of the papers, and also Professor Saxena also wrote the computer programs, and they were used often in the utility companies or even in the Electric Power Research Institute. So that's one of the area I think we really have fun in working on when I was Westinghouse. Then myself, I also working on fatigue and fracture behavior. There are many utilities or that the machine manufacturing, they need quite a lot of fatigue properties of structural components. So they always come to Westinghouse. Well, even I'm at Tennessee, they call and they want to know some of the database, or would ask, under what kind of condition, how is fatigue, what would fatigue causes the final failure, or what kind of fatigue threshold value you have, so we can use it to assess the integrity of structural components such as nuclear reactors. So that will be second topic, fatigue behavior of structural material. And the third topic could be non-destructive evaluation of of metal matrix composites. So at the time, my boss, W.G. Clark, Bill Clark, he has a big program from a corporation, and we are looking at how to inspect the integrity of silicon carbide reinforced aluminum composites. And we did one of the earliest work in this area, try to assess the integrity of metal matrix composite using the non-destructive evaluation. And sometimes the work is also quoted. I didn't know that until some people actually told me about our work at Westinghouse concerning non-destructive evaluation of composite materials. So over three areas: high temperature fracture mechanics, fatigue behavior, and a non-destructive evaluation of metal matrix composites.
Excellent. Thank you for sharing the successful story with us.
Thank you.
I'm sure you got a lot of work. So, did you receive any orders or awards in your career? If so, could you explain?
Yeah, I'm grateful for the opportunity I have. At Westinghouse, I was a senior engineer promoted to fellow engineer. Then at the University of Tennessee, they kindly gave me the Ivan Wachit Chair of Excellence and John Fisher Award, John Fisher Professorship, and then the distinguished professorship. So I'm grateful for the opportunities from the TMS or ASM. We have the TMS Fellows and ASM Fellows, and I also have an award on the Outstanding Service from the Structural Division of TMS organization.
Oh, wonderful. You're well deserved for those awards. Congratulations. Pretty good.
Yes, thank you.
What milestones in industry do you think had the biggest impact to the industry? Could you explain?
Okay, you're asking what kind of milestone we should
had the biggest impact on industry?
I think, I sometimes feel not so comfortable for many big corporations. They all give up basic research. And they should try to do it again because it gives the company some depth. Now, if you only focus on day-to-day type of business, then you don't have the long-term plan. Of course, we understand the stock market, you have to do it nicely, otherwise the corporation is not too good. But I wish that the big bosses in the corporation, they should also pay attention to basic research, because that really gives you some depth. Then you have chance to change to different areas. Otherwise, we are too shallow, we cannot be competitive. So it's important to focus on day-to-day type research. Also, it's important to also consider basic research. That's what happened to Bell Lab. There's so many Nobel Prize winners, and also they have, the company was doing very well, back in the old times, and it'd be nice to see company coming back and focus on basic research rather than just making money, quick money. Yeah.
Oh, wonderful! Thank you.
Thank you.
You have been a professor for almost 27 years. Yes. So in your opinion, what are major challenges to be successful in academia? And then what advice could you possibly offer to young scholars, graduate students, postdoc research associates?
Yeah, it's excellent questions. Certainly, being a faculty member is tough. You have to teach, you have to do service, you have to somehow get your research going, and it's very competitive, especially getting the funding. But I would think if you continue, never give up, then you will have a chance. For example, I just mentioned to you that Professor Yang Hui Gao, my colleague, he and I wrote proposal 7 times before we get our program actually funded 1 year ago. And another example is that we tried to develop this NSF Integrated Graduate Education Research Training Program. It's a sizable program, and my dear colleague, Professor Ray Buchanan, is a scholar and gentleman. Of course, now he's in heaven. So he and I, we work on this IGER proposal. It took us 3 times. Even my wife mentioned to me, well, maybe you attend us, you have no chance. So we continue to try, and the 3rd time is a charm, so we got it. This is our IGER program, so we support many American students. They are all doing quite well because the program is geared for American or permanent resident students. And then another story is that we try to get that MOI program, Major Research Instrumentation Program, or NSF. At the time, it's the highest amount of money, $2 million. Of course, now they expand the program much higher than what we had at that time. And it was very difficult because you had to go through the material division, and you compete with the 2nd level from physics, from chemistry, from engineering division, and go to the 3rd level. So it's very difficult to get this kind of sizable program for the major research instrumentation program. So we also tried 3 times. And we work with Professor Han Chu, my colleague, Professor Shin Wang, Professor Kem Haber, and at that time we failed twice. So my colleague told me that, Peter, you are asking too much. The $2 million, we should cut down to $500K. Only at the time, maybe some of you still remember, Dr. Tom Mason, he was director of the SNS, the $1.4 billion sportation neutron source. Only he and I, we decided we should continue. So we tried a 3rd time where we got the money to build up, the Vulcan is, you are going to, Dr. Gao, you are going to sportation neutron source doing the research, you will see the instrument. So it was difficult. But the key I can see is that never give up. The reason is this. I have some friends come to visit us. They're Nobel Prize winners in their department. So I'm certainly curious. I asked him, how about those Nobel Prize winners? Is it easier for them to get money? And he told me that it's difficult, even for the Nobel Prize winner. And many of my colleagues, they are NAE member, National Academy of Engineering or National Academy of Science. It's also difficult for them to get money. And so the key, I understand that you just have to continue, never give up. And some of my colleagues, they are very distinguished, but they never give up. Some of them may tell me that, Peter, I wrote 12 proposals last year, maybe I get 1 or 0. But I know he has a kind of spirit, continue to write proposals, he's become very successful. But if you don't continue, then it's tough, especially in the US. That is a totally different system. As Dr. Gao knows, in China, if you get Nobel Prize, okay, and if you become a NAE equivalent, your life is set. I mean, they simply give you money. Okay, they see your status, they give you money. But in US, it's different. Everything is so competitive. You can see we go to NSF review proposals sometimes. If a proposal written by Nobel Prize winner, if the proposal is not well written, it would be very difficult to get funded, even though people recognize this person, get Nobel Prize or, has NAE or NAS, but still we have to write excellent proposals. Everything just on a fair competition, and we just have to better prepare ourselves and be persistent, continue toward what we like to do, and you will be successful, even though we have lots of frustrations. But never give up. Be persistent, you'll be successful for the younger generations.
Okay, thank you very much.
Thank you.
Now I'm going to switch to questions about membership society. The first one is, When did you first hear about AIME and or your membership society? How did your involvement progress over the years?
Well, excellent questions. I became a member of ASM and TMS since I was in graduate school. And my advisor, Maurice Ifan, is always very supportive of this kind of society meetings. So he always sent us to meetings. So since I went to Northwestern, I'm always going to TMS and also ASM meeting every year. And I continue that way even when I was at Westinghouse. And I think back about my career, I think the society really, TMS or ASM really helped me quite a lot. It gave me an opportunity to present my work and also give us a chance to organize symposium, as Dr. Gao also organized many symposium, and get lots of networking going on in societies. Sometimes myself need lots of help. Sometimes other people need help, so we shall work together, make the society better. So I strongly suggest we should encourage our team member coming here to give a presentation. For example, this time we have 5 team members from a group coming to TMS meetings, and they all give a presentation or posters, and this is important because I went through the same thing, even though it's difficult to support students to come because funding is so difficult to get, but we all try our best to support the students and to come to a TMS meeting. I even try to encourage some of my colleagues at Tennessee in mechanical engineering or even in mathematics. And this year there are several of them from mechanical engineering, from physics, all come to TMS meeting to present their work related to high entropy error, which Dr. Gao is an expert at it.
Okay, thank you. So second question is, how has membership benefited you in your career, and how do you see society benefiting people in the industry today?
How would that benefit the industry people?
Yeah, so how has membership benefited you in your career?
Yeah.
And likewise, how do you see society benefiting people in the industry today?
Okay, I would think it benefits tremendously. Without TMS, I don't know what I'm going to do. Okay, they give me an opportunity to present papers, organize symposium, encourage my students or even postdocs to come here to attend the meeting. They offer lots of opportunities. For example, Chong-ho is looking for his job. As Dr. Gao knows, we co-advise Chong-ho, and I encourage come here to give presentations, and because I want to see our team members successful. If the team members successful, then our group, get good reputations. And so the same to apply to many other my colleagues' group too. And so the TMS meeting is always very helpful to my career development, and I just cannot live without it. I come to almost every TMS meeting since I was in graduate school. And then it's also helpful for the people from industry, because I was at Westinghouse for 13 years, and I believe go to almost every TMS meeting or ASM meeting. Sometimes many times go to ASTM, American Society for Testing and Materials. So they strongly encourage people to be involved with society meeting. You have so much network type opportunities. Also, you can verify if your work is good or bad, because you get critique from people and get lots of interaction with other people. So it's a very good thing to come to society meeting, especially AIME type meeting. That is my main society membership. So it's wonderful to have this society going.
Okay, thank you. So if you were to recommend your membership society to a new graduate student, what would you tell him or her about it?
I would say, if you want to be successful in your career, it's essential to have this kind of membership. I'm teaching this month. I'm teaching undergraduate courses on mechanical behavioral materials, and I think 4 or 5 of our undergraduate students coming to the meeting. And before they come, I told them that it's important to come here, also enter into competitions and try to give presentations. Some of them also could give presentation, and we always have rehearsal at our group meeting. Everyone is welcome to come, and I strongly support students to come to TMS meeting if my budget is allowed it.
Okay, good. In your opinion, what do we do to attract young people to the society, to the industry? To the industry, sorry.
Okay, attract people. I think it's probably good, like a TMS meeting or ASM meeting. It's good to have some more industry people to come, and we do have some. Of course, people may tend to say that for TMS, they tend to have more academics. But I think TMS should also continue to try your best to encourage more people from industry. And when people come, like Chong-ho is graduating, and you can see how good he is, and try to offer him a job, even though he's more interested in academic type positions. And I always remember I have a very outstanding student, Ying Zhang. Now she's teaching at Tennessee Tech, and she's the director of their manufacturing center. She gave a beautiful TMS meetings. I always remember that. She speaks very good English. And after her talk, it's on coatings. It's a big conference, and many people just come around her, ask her many, many questions. Eventually, she got at least one offer from industry. So it's good to have more people from industry to attend TMS. I think it would be nice for TMS to continue pursuing this area besides the involvement from academia. And that would be very good to attract students to go to industry, and also the industry people can find the people they need from the society.
Okay, good, wonderful. So we're going to last phrase of questions. So the first one is, what has made working in the field meaningful to you, or what has been your favorite part of working in the field? In your field.
In field. It's always a pleasure for me to work in some area I'm interested in. As I asked my professor, what would you like to do if you have chance again? He said, Peter, I want to study material scientist. I have similar phenomenon situation, but I may, if I have a chance again, I may get my MD, PhD, okay, and study materials. And it's just nice to, especially from educational point of view, you see a student coming in, they don't know too much. After 4 or 5 years, as Dr. Cao knows, we are co-advising many students. They write quite well, and they publish many papers. And Dr. Cao knows, we have a student, Ray Fong, and he went through very competitive competition that Oak Ridge is just special positions at the sporulation neutron source. They have probably 40, 50, or 60 people apply for this position. It's a position you don't need to tie with any beamline. You basically go in there, focus on science. So it's a very, very ideal situation, especially for someone who wants to go to teach. Of course, it's very competitive. So they eventually, out of 40, 50, or 60 people, they invite about 4 people, and 2 of them are from our group, that is Chong-ho and Ray. Then eventually Ray got the positions, and you see your student find a top-notch job, and you're very happy about that. I'm sure they will continue to be successful. So in academia, in the research area, you see your student graduated, and they publish many good papers, find a good position. I'm sure Dr. Kao may have a similar kind of feeling that we are satisfied. And then doing research, I enjoy, encourage students to write papers. And because as I learned from Westinghouse, and the writing is learning. So I always try to encourage our team member to write papers, publish high quality papers, and so they could have a better chance to find a better job. And we do see many students going in this direction, so I feel happy about that. Dr. Gao and I, we co-advise currently previous, that Ray Fong and also Chong Ho, they are very outstanding students. And I'm sure Dr. Gao feel good that they all do quite well, and they send paper to very good journals. And it's just a pleasure to see they become mature. We continue hope and pray they do well in their future. And it's doing research. It's interesting also. It's a pleasure to see that younger generations, they become better and than we. Okay, for example, I didn't get a job at GE Schenectady, General Electric Corporate Research and Development Center. That's a top-notch places, and I'm happy to see two of our team members working there, Liang Jiang and Shannon Huang. They can do better than what I had before. So it's a pleasure to see our next generation doing much better than we can do. And because we are here to help students and make sure they could be successful or doing much better than what we have.
Yeah, indeed, you have doing an excellent job in training a lot of top quality students.
Well, thank you.
So,
well, you help out quite a lot. We appreciate that. Yeah.
So, also, what advice would you have for today's young leaders in the engineering profession? Do you have any advice for today's young leaders in the professions? Yeah,
I think it's good to continue attending the society meetings and make contributions. Depends on what kind of position you are in. It's nice to always do something new and unique and help other people, friends, and certainly yourself also need help too, and continue to work together. So we have lots of active networking and help each other, and the society can become better. And overall, we like to do high quality work. It's important. And so, all those young leaders can become very successful. If you publish high quality papers, your name will be known, your impact in the field, and people recognize you.
Wonderful, thank you. Professor Liaw, so thank you very much for sharing that personal experience with us. So, so additional question is, do you have additional advice to younger generations, like even graduate students, to shape their career?
Yeah, that's very good questions. Maybe we can expand it to graduate student and postdoc, or even that younger professionals. Besides what I talk about, that we got to be persistent in whatever we are doing, especially in the academic setting, or even industry too. I mean, many times we have to write proposals. We got to be persistent. Besides that, I think to be successful, it's important to have a grateful mind. You have to remember people help you, and always keep this in mind. Rather than people help you, never remember that and do whatever you want. We have to be a very grateful person. And also, it's important to be dedicated and devoted. If you are not dedicated, devoted, you just cannot be competitive. This certainly is a very excellent society. Also, is very competitive. So, if you want to succeed in a particular area, you got to be totally devoted and dedicated. There's no other way from what I can see. And on the other hand, if someone is very dedicated and very devoted, as we see many successful people, then you will be successful, because this is a wonderful society. It gives us lots of opportunities, but it also demands us to be to have the total dedication and total devotion to be successful. And also, as I mentioned, be persistent, be grateful for what we have, be grateful that we remember who helped us so that we can be successful. If you are not grateful, always just take advantage of other people, then people may not like to work with you anymore. So it's absolutely critical to be grateful.
Thank you.
Thank you.
So, do you mind asking a personal question?
Yes, of course.
My observation is that you're working so hard. You almost like I was thinking, Professor, you now even don't sleep. So how are you? How did you make it to balance your life and then work and profession? I mean, how your wife never complain, your kids never complain. Did you have enough time to spend time with your family? Are they happy with your dedication to work?
Yeah, that's a very good question. We somehow to balance the life and work. I think it's important to pay attention to both of them, so you don't regret. And of course, I try my best to see how can I benefit. Do well on both sides. And as Dr. Gao mentioned, that's certainly I work pretty hard. But I also try to, hopefully my wife will be happy, my kids will be happy. Of course, I may not be 100%, but I try my best, especially when it comes to granddaughter or grandson. I think I should pay more attention to them. Yeah, but I think it's important to have balance.
Okay, thank you very much.
Thank you.
Is there anything else that you would like to discuss?
Oh, that's also a very good question. Throughout my life, I have so many friends help me out, our team members, students. I learned quite a lot from those students, and many of friends. We all interact together, including Dr. Michael Gao. It's just a pleasure to work together, and so we can understand some particular topic well, especially now. Dr. Gao and I, we are all interested in high entropy alloys. He has a theoretical background, and I'm more experimental in nature. And it's nice to let our team member know that in order to do good work, you got to use both theory and experiments. And certainly, we cannot do everything. And sometimes we need help, like in theory part, Dr. Gao is a super-duper theory teacher on high entropy alloys, and he helps so much. So we are sure that our younger generation, they know, both we have to combine experiment theory to do a high-quality research. And I hope the younger generation can carry on. And of course, this only from an academic viewpoint, but even for industry, it's important to also focus on experiment theory. That's why I also give advice to our undergraduate students, because when you work in industry, you tell your boss, I think you should increase the strength, and it's much better to say we should increase by 20% or 30%. There's a quantitative value there, so it's always important to include both theory and experiments together to be successful.
Okay, wonderful. So in conclusion, that what a fascinating career and life you have had, and then what a pleasure it's been to spend this time with you. And thank you so much again for your willingness and to share your story with the AIME. Thank you very much.
Yeah, thank you very much for this opportunity, Michelle and Dr. Michael Gao. It's a pleasure for me to be here. Hopefully what we discuss will be helpful for the younger generation. We see much more successful younger generation, especially than I, and we can carry on generation by generations. Thank you.
Okay, thank you.